Here we are talking about the chemical level of organization. Chemistry is the science that deals with the structure of matter. And matter is anything that takes up space and has mass. And here on Earth, we will equate mass with weight. So what exactly does that mean? That means that mass and weight are exactly the same thing here on Earth. Now, if we were in outer space, that would be a different story. But we're talking about here on Earth. So again, mass and weight are exactly the same thing. So if I ask you something on a test like, what is the mass of something? You can just say, what is its weight? It's exactly the same thing. Now, there are three different states of this thing called matter, and matter is anything in the world. So matter includes your couch, your chair, your hair, your face, your organs. The air is also made of matter. So it's anything that's in this world is made of what we call matter. And again, there are three states of matter. There are solid, liquid, and gas. There are two other states, but we don't go over those. So it's solid, liquid, and gas. So something can be solid, a liquid, or gas. Those are the three different types of matter. Next, as we said, mass and weight are exactly the same thing here on Earth. And everything that exists on this Earth is made of matter. The smallest unit of that, the smallest stable unit of matter, again, not the smallest unit, but the smallest stable unit, is in fact an atom. So, if you remember, we talked about chemicals and molecules form cells, cells form tissues, and tissues form organs. But if you remember, chemicals and molecules form a cell. A cell is the smallest living unit, but atoms, billions of atoms, make up a single cell. So if a cell is the smallest living thing, then anything smaller than it, or anything that makes it up, is not living. So atoms, therefore, are not alive. They are stable units, in fact, the smallest stable unit, but they are not, in fact, alive. There are three things that make up an atom, and those are protons, electrons, and neutrons. Protons, electrons, and neutrons make up this thing called an atom. Now remember, an atom is going to be the smallest stable unit of matter. Well, if that's the smallest stable unit of matter, then anything that makes it up is not in fact stable. It is not stable. So protons, electrons, and neutrons are not stable. They are the pieces that make up an atom. So if you want to say there are three parts to a hamburger, there is the bun, the patty, and the ketchup. Those are the three things that make up a burger. So the protons, electrons, neutrons are a lot like the bun, the beef patty, and the ketchup. They're all parts that make up the larger thing called the atom, the burger. In terms of weight, protons are the heaviest, electrons are the lightest, and in between that are neutrons. So protons are the largest and the heaviest. Neutrons are going to be below that, and electrons are the lightest in weight. Now, another way of saying that is, remember, weight is the same thing as mass here on Earth. So if I say that protons have the most mass, they therefore have the greatest weight. If I say electrons are the lightest, therefore they are the least massive. Because again, mass and weight are exactly the same thing. Now, an important point to remember is that atoms normally equal the number of, in atoms, normally the number of protons equals the number of electrons. So, again, if you have 5 protons, normally you're going to have 5 electrons. But that's not always the case. Not every atom is going to have exactly the same number of protons and exactly the same number of electrons. And usually where that happens is in ions. In ions, you have an unequal number of protons and electrons. Now, the number of protons that is in an atom is called its atomic number. So, if an atom has 8 protons, another way of saying that is its atomic number is 8. If I say that the number of protons in an atom is 15, The atomic number, therefore, is 15. If I say to you the atomic number is 7, then what we're saying is that the total number of protons that that atom has is 7. Now, protons exist in an area called the nucleus of an atom. Remember, the nucleus of an atom is not the same thing as the nucleus of a cell. Millions and millions and millions and millions of atoms make up a cell. So if millions of atoms make up a cell, and protons and neutrons are parts of an atom, clearly the nucleus of an atom is smaller than the nucleus of a cell. So here we see that we have a proton. If we look at the one to the left, we see a proton in the center. The proton in the center is located in an area called the nucleus. If we look in the middle, we see the proton and neutron located in the nucleus. And if we look at this, we see that there's an electron that is outside of the protons and neutrons. That electron is moving extremely fast, and it forms what we call an electron cloud. But when we physically draw out an electron cloud, we term it an electron shell. And electrons exist in an electron shell. Electrons are going to exist in that electron shell. And as a rule of thumb, you always want to remember that you always are going to want to have a filled electron shell if it can happen. But we'll get to that in a bit. Now, here are the elements, the important elements I want you to remember. And we have oxygen, carbon, H is hydrogen, N is nitrogen, Ca is calcium, P is phosphorus, K you have to know as potassium or kalemia, N is sodium, also known as natremia. Again, that's natremia. Cl is chlorine, not chloride, chlorine. Mg is magnesium. S is sulfur. Fe is iron or ferrous. I is iodine. And NO is nitric oxide. So when we look at O is an element. Elements are atoms. So atoms are classified based on their atomic numbers, the number of protons. Remember, atomic number and number of protons are exactly the same. And anything with the same number of protons, or again, another way of saying that, anything with the same atomic number is going to be part of the same element. So if we talk about one of these elements, all elements of oxygen are going to have the same number of protons. They may have a different number of neutrons, they may have a different number of electrons, but all oxygen elements have the same number of protons. So let me give you an example. Let's say that you have two oxygen atoms, and they both contain 8 protons in their nucleus. But one contains 2 electrons, and the other one contains 2 electrons and 1 neutron. The difference is between the two oxygens is that one has a neutron and the other one does not. Therefore, they are the same elements because they contain the same number of protons, but they are not the same atoms. So again, if they contain the same number of protons, they are the same element. If they differ in any part of the protons, neutrons, and electrons, they are a different atom. So again, as each element includes all the atoms that have the same number of protons, therefore the same atomic number. So again, that's exactly what I just said, which is any atom that has the same number of protons is considered to be the same element. So if you have 2 atoms that have the same number of protons, and I ask you, are they the same element? your answer should always be yes if they have the same number of protons. If they have different numbers of protons, if you have two atoms with different numbers of protons, they are not the same element. The mass number is the total number of protons plus the total number of neutrons. So if I say to you, an element has 7 protons and 7 neutrons, and I ask you what is the mass number, your answer should be 14, because there is 7 protons and there are 7 neutrons. The mass number is the number of protons plus the total number of neutrons. So 7 protons, 7 neutrons, 7 plus 7 equals 14. Therefore, the mass number equals 14. Here we're looking at isotopes. Isotopes are elements with the same number of protons but with a different number of neutrons. So if you look at the comparison between the one on the left and the one in the middle, they both contain the same number of protons. So being that they contain the same number of protons, they are therefore the same element. That you should agree upon. The next question I could ask you is, are they the same atoms? Is the one on the left and the one in the middle the same atom? And the answer is no. They are both going to contain 1 proton. They are both going to contain 1 electron. But they differ in the number of neutrons. The one on the left has no neutrons. The one in the middle has 1 neutron. So how do we name that? If the one on the left and the one in the middle contain the same number of protons, which they do, but contain a different number of neutrons, which they do, we call them isotopes. I must show you 2 atoms or describe 2 atoms to you in order for you to know that they are isotopes of each other. So for example, if the one on the left and the one on the right contain the same number of protons but a different number of neutrons, which they do, they therefore are called isotopes.